right into this. Okay. So today we are talking sectors, and sectors is talking about area. Okay. Um, just to remind ourselves, we're focused on area. What's that formula for area of a circle? Area of a circle is pi r squared. Not to be confused with the circumference. Again, area of a circle, that is if you were to go through and try to paint and cover that entire region inside of that circle. The circumference of a circle is if you were to walk it around, that's the circumference, and that is 2 pi r. That's the perimeter of a circle. So for all of that, please make sure you keep those two formulas separated. Again, on Friday, your responsibility, if you want to have those formula sheets, that's cool. But you got to remind me to pass those out. Okay? All right. So off of here, okay, let's just jump right into some of this. Okay. Like we do with arc length, trying to discover that formula. We've already basically discovered the formula. The formula between arc length and the sector are one and the same. Only difference is one's area and one's circumference. Find the area of the full circle. Okay. Find the area of that full circle in terms of pi. So I should see pi in your answer. Everything we said last week revolves around knowing your radius. So we obviously have the radius, as Eric reminded us, it's pi r squared. So the area of that full circle is what? 100 pi, right? And this is two-dimensional. So we say what? Inches squared, right? It's area. It's 2 dimensions, inches squared. Now, after that, okay, we don't have a full circle now, do we? We have ourselves half of a circle. And with that half of a circle, what's the area of that half circle then? It's just what? 50 pi, duh. Yeah, don't overthink it or anything like that. Okay, give me a second, I'm gonna bring it down just a bit. 50 pi. Okay. And what's that last one? I mean, you immediately need that, right? Nothing crazy off there. It's immediately 25 pi, because why did you say 25 pi? It's a what? It's a quarter. It's a quarter of a circle, right? Now, coming back around to that, like we did with arc length the other day, again, I know it's math, and I know we got tons and tons and tons of formulas out there. And I try not to throw as tons of formulas out there as what I have to. This is what I'm trying to get you to think about. It's a fraction of something. It's a fraction of an area, a fraction of a circumference. And this is what that is. It's a fraction of the area. You said immediately it's half of a circle, 50 pi. That's what you said. So how do we get to that 50 pi? A full circle, which was 100, and what is a half of 360? 180 over 360 times what? 100 pi. That's exactly what we did on arc length. You said 25 pi, right? Why did you say 25 pi? 25 pi. It's a quarter, right? What does it represent out of 360? 90 out of 360, right? That's a quarter. Always times a full circle. Or sorry, times the full area I should say, which is 100 pi. So that's why, again, the SAT is not going to give you those two formulas. They're going to want you to think about it's a fraction of the circumference, a fraction of the area. So that's our formula. That's our formula given for today. The 2 days here, they're not anything totally similar. It's just one is a fraction of the circumference, and the area is a fraction of the area of a circle is a fraction of the circle times the times the area. That's it. There's nothing like super crazy between the two formulas. You just gotta make sure you're reading carefully. One says the length of the arc, the other one says the sector. And the sector is that. Okay. So now I say a sector. That's what we just did. What you did is when we said a half of a circle, a quarter of a circle. When you start talking about a partial area, that's what we call as a sector. Okay. A partial area of a circle That is what we call a sector. Okay, I said that like it was anything. That's actually what we define as a sector. Okay, so a sector is right there our definition. It's a region bounded by an arc of the circle and then the two radii, and that's what we just had. Here is the arc of the circle bounded by then two radii. Arc of the circle bounded by two radii. Those are sectors. Sectors can be made out of minor arcs, major arcs, semicircles, all of those. Okay. We name a sector by using the two arcs endpoints and then the center. So naming that right above, we'll name that as ARC, sector ARC. Okay. So when we name a sector here, we just will say a sector ARC, and we'll use the center as in the middle as well. Okay. Don't overthink this stuff. Okay. And then there's our journal formula that you guys already journalized out from last week, and we just journalize out one more time again. So box it in, highlight it where we need to, but that is our journal formula, which we replace the area formula for the circumference formula. It's one and the same. So let's go, let's do it. It's not a nice quarter, it's not a nice half. It is here 100 degrees. Find me the area of this sector ACB. So the biggest thing I can tell you on Friday is students don't necessarily read very carefully. And they find the arc length when they find the sector or vice versa. So it's going to state clearly, find me the area of the sector. So I always go, hey, find me the area of a full circle. In this case, the area of a full circle, radius is given. 6 squared is, yep, 36 pi. And then whatever happens to be the degree of that arc we're looking at. The degree of that arc in this case is 100 degrees. It's not 90 degrees, it's not 180 degrees. We're looking at 100 out of 360. So then, got my calculator, finish it off. Okay? Just like we did with arc length. So 100 over what? 360 times what? 36. So we get 10 pi. And in this one here, they're also asking us to round it to nearest tenth. We know how to round to nearest tenth. Go back to your calculator and punch in 10 pi. Now we're going to punch in 10 pi. So 10 pi, and then your calculator gives you that long decimal. Nearest tenth we know is 1 decimal. So what is it? 31.4 meters squared. Chloe's at the door. Go find me the next one. Guys, as I go to the next one. What do we got on the next one? That's a big old one. Pac-Man here. Okay. Radius is represented. 13 squared. 13 squared, if you need to do that off to the side in your head there, 13 squared is 169 pi. So there's my full circle. If we are to find the area of that full circle, 169 pi. We're not. We're finding most of it, but not quite. 315 out of 360. Go back to that calculator of ours. Times, what is it again? 169. Again, it's a nice terminating decimal, but typically we rewrite this as a fraction pi. Okay? And sure, it's not a stellar fraction there, but typically that's how we write them. Okay? If you gave it to me, it's not wrong. Just formatting wise, we really write it as a fraction pi. So 1183 over 8 pi centimeters squared. If it's not a terminating decimal, for sure, don't round that on your own. Don't give me a rounded pi, okay? Terminating pi, that's okay, but we prefer fraction pies. Okay, now finish it off. Nearest tenth again. So, excuse me, 1183 over 8 pi, and nearest tenth again. Somebody at what? 464 point. What is it? 6 centimeters squared. Okay. Thanks, Brett.
Yeah.
Nothing crazy. Find me a fraction of the area. Okay. Now let's take a look at the next one here. Reverse it. I'll reverse this one. I give you the sector. So this time we're given the sector. We're given the 36 pi. We're given the sector. I don't know what the radius is. I don't know the radius, but I do know still the arc. I don't know what the full circle is. I do know what the sector is. I do know what the arc was. I don't know what the full circle was. So now we need to work it backwards. We got to take our equation skills and work it backwards here. So let's do it out. How are we going to solve for r? It's a quadratic. It's our quadratic skills in action. So we're going to solve this out, but I need to clean that sucker up. That's ugly. Those pi's are going to cancel, hopefully you realize. Those pi's will cancel. And when I cancel those pi's, I'm going to take this thing by square roots. But I still got to first get rid of that 300 over 360. I'll get rid of that 300 over 360. How are we going to get rid of 300 over 360? Multiply by the reciprocal, right? By multiplying by 360 over 300 to both sides, multiplying by the reciprocal, nothing crazy off that. That's going to get rid of 360, 300, and there's the r squared. Thank you. 360s cancel, 300s cancel, right hand side. All right, just let your calculator clean that thing up. Don't try to do it on your own. Just let your calculator do it. 360 over 300 times what? 36. 43.2. Now, I'm about to square root that thing. I don't care if it's a decimal or a fraction here in a second. I'll just let my calculator take care of it. Let's see what happens off that. Okay. Square root 43.2 now. What's the square root of 43.2 do for me? That's the deep side there. Okay. Now, give me a second there. Let me go back a second. See if anything happens off that. I want to see something here. Nope, that doesn't do anything. What did we just say? 43.2. So in this instance, best we can do, and it doesn't tell me anything around it here, and we're not going to be able to simplify that or anything like that. So we're going to go ahead and just do our best to say round it to the nearest 10. 6.6 meters is the best we can say here. Okay. You can leave it as the square root of 43.2, but it's as ugly as it is. Okay. It didn't come out to be perfect or anything like that. Okay. So 6.6 is about what the radius is going to be in order to get us that sector of 36 pi. Okay. All right. Let's take it next door. Find me the area of that next one there. Are we finding the area of the full circle? No, just the area that's where contained in quadrant 2, which is this piece right here. And when they say the area that's contained in quadrant 2, what is that code for? It's code for what? A quarter, right? It's code for being a quarter, or in this case, it's actually code for what we're talking about today. It's code for a sector. And as Caden then said, when he said a quarter, even if we didn't know what a sector was, you still can easily find that out. But we now know that those are called sectors. So go at it. A fourth of that area, or 90 over 360 of that full circle. What's the radius of that full circle? Radius is what? 1, 2, 3, 4, 5. Looks like the radius is 5. And what is 5 squared? 25. 25, right? And that's it. Okay, 25 pi. With that 25 pi, 25, a quarter of 25. Is it, excuse me, it's not a whole number, is it? So 6.25, but change it back to a fraction. 25 fourths, makes sense. When Caden said a quarter, we were going to take a quarter of whatever that was, and a quarter of 25 is 25 fourths. Okay? All right, go with the last one here and give you guys some time to work today. I think that's the last one here. Last one. Go start it off. Person wants to start from starting location of 0, 5. Where's 0, 5 at? Right there, starting there. Okay, counterclockwise to 5, 0. What direction is counterclockwise? Yep, counterclockwise. 5, 0. Where's 5, 0? Keep going, keep going. Stop in here, don't we? What do we just represent then? How far did that person walk? What's that?
3 sectors.
Okay, 3 sectors, 3 90s, right? Which represents how much? 270, which is 3 fourths. Now, is this a sector though? It's not a sector. I know what you're talking about. This isn't dealing with sectors. This is dealing with what? We're dealing with length. We're dealing with partial perimeter. We're dealing with arc length here. So even though today we're focusing on our sectors, we're not talking about the inside of this, are we? We're talking about the perimeter of that circle. So we're back to arc length. So as we walk around this circle here, we're dealing with arc length. So we're doing the same thing. Exact same startup, a fraction of something, but in this case it's a fraction of what? 2 pi r. 2 pi r. And what is that radius here? Radius is still 5, but it's not 25 pi, is it? What is it? 10 pi, because it's 2 pi r, right? This is where those silly mistakes are going to happen on Friday. Let's get them over our system today, this week. It's 2 pi r. You'll have your formulas out, but you got to know arc length is 2 pi r. So it's not 25 pi, it's what again? It's 10 pi. So those are the silly mistakes. Okay? I'm going to say it's silly, it's just things to watch out for. 3 fourths, 270 out of 360 times, what is it, 10? 7.5. Math it out, fraction it out. 15 halves. Oh, no, 15 halves is fine. But it does say to nearest tenth. 7.5 pi or 15 halves pi, whatever you want to do. It does say to nearest tenth. So how far? 23.6 units. Okay, and units, remember, units is 1 dimension. That's 1 dimension there. Okay? It's all about practice. You and I can keep doing a few more up here, but you got to practice now. Making sure you're paying attention to perimeter versus area. Okay, so I'll let it be.